This chapter test review of chapter 3. I'm going to start on question 33. Questions 1 through 32 for vocabulary, so you should be able to look those up. Two lines that do not intersect are parallel. That is sometimes true because they could be skew. Okay, there's no distinction on whether they're coplanar or non-coplanar here, so we just know that two lines are not intersecting, so they are sometimes parallel. If two lines are intersected by a transversal, then same-side anterior angles are supplementary. That again is sometimes. The two lines could look like that, okay, to where they are parallel. So then yes, this angle here and that angle there would be supplementary. But it says nothing about the two lines being parallel, so they could look something like that, where that angle there and that angle there are no longer supplementary. This idea only occurs when the lines are parallel. Skew lines are lines that are coplanar. That is never. The key part of this definition for skew lines is that they are lines that are non-coplanar. If two parallel lines are intersected by a transversal, then same-side anterior angles are complementary. But that is never true. The angles are always supplementary. Here we have some parallel lines cut by a transversal. What I suggest doing is highlighting the two parallel lines. So that one and that one. And then choose a transversal. Doesn't really matter which one you choose. If you choose this one, okay, we recognize that that is a right angle there, and that should correspond to that angle there. So X is also a right angle. So we've got this angle here to be 90 degrees. So X, 90 degrees. Okay. Looking at those two transversal, or those two parallel lines again, and perhaps a different transversal. Maybe we look at that transversal. Now we're looking at this angle here and this angle here being supplementary because they're same side anterior angles. So we'll take 3y minus 8 plus y plus 12 equals 180 degrees. That's going to give me 4y. A negative 8 plus 12 would be a positive 4 equals 180. Subtract 4 from both sides. So we get 4y equals 176. Divide by 4. And that's going to give me 44. Okay, so y is 44 degrees. Now if I want to find z, there's several approaches I can use to find z. I suggest maybe now that you know that y is 44, this angle here is going to be 52. It's 44 plus 12. Oh, sorry, not 52, 56. Okay. So if that's 56 and we knew that this was a 90-degree angle, we should also know that these two angles here are going to add up to 90 because this one out here, that angle there, and that angle there form that straight line. So those three angles, that one, and that one should add up to 180. So those two together should add up to 90. So z plus 56 is equal to 90. So z is going to be 34 then. Another way to do it is to look at that angle there and this angle here and know that they should be supplementary because they're same side anterior angles. So you're going to say 90 plus y plus 12 plus z is equal to 180. Now we know that y was 44, so I'll substitute 44 in there. I can go ahead and subtract all this stuff over, and I'm still going to get z to be 34 degrees. Okay, with this one, these two lines here are parallel. We've seen this one in class, so this is an example that we did in class. So these two lines are parallel, cut by the transversal. So we're looking at that parallel line, and you've got a choice here of the transversals you want to look at. I think this is probably the best transversal to look at, for the reason that this angle here, 80 degrees, along with this angle of 40 and this angle of y. So 40 plus y, that angle, plus the 80 that you have. Okay, the entire green angle and the entire yellow angle, they're same side interior angles. So that should equal 180. So that's going to tell me that y then is going to be 60 when I do the math. Here we saw this question in some of our notes. We have that parallel line cut by that transversal. So that tells us then that the angles that they're referencing here, that angle there and that angle there, are corresponding angles. And corresponding angles then, if the lines are parallel, corresponding angles are congruent. Okay. Subtract x from both sides, you get 2x minus 10 equals 40. Add 10 to both sides, 2x is equal to 50. Then x is 25. Alright. Now, that would go there. Now they want 3x minus 10. Well, 3 times 25 is 75 minus 10 is 65. And this x plus 40 is also 65. The fact that those two things are the same should tell you that this equation was correct. This is pretty much the same type of question. So assume that the lines that look parallel are parallel. So that's talking about the top and bottom lines. That's parallel to that. If we use that transversal there, that's telling us that 4x and x plus 30 are going to be supplementary angles. So we're going to say 4x plus x plus 30 equals 180. That's 5x. Will end up being equal to 150. X then is going to be 30. So that's that option there. Okay. If x is 30, they're asking now, what is the measure of angle 1? Well, measure of angle 1 is this angle down here. Okay. So remember angle 1, this angle here of x plus 30 and angle 1 they form a linear pair, so they're supplementary. So this angle here, that angle if x is 30, that angle 60, so angle 1 has to be 120. This 5x minus 25, just there to throw you off. Okay, you don't necessarily need that for this particular problem. Okay, 41, we saw this one in class as well. Hopefully you guys are starting to realize that a lot of the problems that we see in class start to show up on tests. Probably the quickest relationship that we see is that this angle, or sorry, that line and that line are parallel. Using that transversal, we now can show that this angle here and this angle here are same side interior, so they're supplementary. So x has to be 70 degrees. Okay. Now, if we look at the exact same parallel lines, but then look at this bottom transversal, that transversal there, and we can look at these two angles being complementary. So that angle there, and that angle there are complementary. Not complement, I'm sorry, corresponding. They're corresponding, so they should be congruent. So say z plus 32 is equal to 5y plus 10. Okay. Now that equation has two variables in it, so I can't solve it right away, but I'm not going to erase it. I'm going to leave it because I might need it later. Okay. I start looking then for other relationships. Maybe I have to look at a different pair of parallel lines. So let's look at that parallel line, and now that transversal. Okay, so now that's going to provide us that angle there and that angle there. They are corresponding as well. Okay, so this angle here was 70, so we'll say 5y plus 10 is equal to 70. 5y then it will equal 60, and y will end up being 12. Okay, now that I know that y is 12, I can come back up here and say that z plus 32 is equal to 5 times 12 plus 10. So z plus 32 is equal to 60 plus 10. Z plus 32 is equal to 70. Subtract 32 from both sides, and that's going to give me z to be 38. Okay, so z was 38, y was 12, and x was 70. Okay, this question here is finding the value of x for which m is parallel to n. So let's just assume that m and n are parallel. The angles that they're talking about, that angle there and that angle there, would be alternate x-shear angles. And if the lines are parallel, those would be congruent. So let's force them to be congruent. Let's say that their measurements are equal, and that will then force the lines to be parallel. So then I'll subtract 3x from both sides, I'll add 30 to both sides, and for my particular problem I get x to be 39. With this one it says which sides of quadrilateral PLAN must be parallel. If you remember doing one of these in class, we stated that when we name this figure, any one of these letters can, or any one of these vertices can be P, but then when I go to L, L either has to be this vertice up here or that vertice down there. Okay, I can't make this one L. I can't skip vertices. So that's going to be, I'm going to let that one be L, this one to be A, and this one to be N. You could have made a quadrilateral that looks like this and said that's P, that's L, that's A, and that's N. Either one is fine. But it says P is 56, so that's 56 degrees. L is 43. A is 137. And N is 124. Okay. If I did that over here, this would be 56. L is 43. N is 124. And A is 137. Now, we have to use our idea of, in this case, supplementary angles, because that angle there and that angle there are supplementary. So if I looked at that line and that line being parallel and cut by that transversal, okay, we would say that AN is parallel to PL, okay, by the converse of the same side interior angles postulate. Same thing over here. Now we're looking at that angle. Oh, There we go. Still looking over here, I guess we could look at those two angles, that angle of N and that angle of P. They are also supplementary and they're same side interior. Okay, so AN is parallel to PL by both those statements. Okay, over here again, that angle and that angle are same side interior, so that line and that line are parallel cut by that transversal, and then likewise this angle and that angle are same side interior, so that line again and that line are parallel cut by that transversal. So either way, again, AL I'm sorry, not AL, AN, this line here, the bottom line, is parallel to the top line. Okay, and the LA is a transversal and PN is a transversal. Okay, what people want to do, and you can't do this, is that if I had that figure P L A N and this was 56, L was 43, A was 137, and N is 124. What a lot of people are going to want to do is say something about that angle and that angle. Well, we don't have any relationship. They're not equal. They're not supplementary. Therefore, I can't make any argument about that line and that line being parallel because of that transversal. Okay, because that angle and that angle are not supplementary. So just make sure that you understand that. If two lines are parallel to a third line, then the original two lines are perpendicular to one another. That is false. If two lines are parallel to a third line, then the original two lines should be parallel to one another. If you have trouble convincing yourself of that, draw a picture of two lines being parallel to a third line and see that they're all three parallel to one another. They're all three going in the same direction, have the same slope. So how many lines pass through point P that are parallel to the given line? We talked about this in class. That is only one. Okay, there is only one line that goes through P that is parallel to the given line. There's an infinite number of lines that go through P, but all of them except for the one that I've drawn here will intersect this given line at some point. Okay, it says solve for x. This is using the triangle angle of sum theorem. We know that this is 90, that's 21, so far I've used 111 degrees for my triangle. So this angle here needs to be 69 degrees. Okay. Now that I know that that's 69, I know that this is 90. These three angles, that angle there, that angle there, and then this angle here, they should all three add up to 180. So I'll say 69 plus 90 plus x equals 180. That will then allow me to solve for x. X ends up being 21. Another way of thinking about that is this angle here is a is an exterior angle, and this angle and that angle are remote interior. So this angle here should add up to 111, and I already know 90 of it, so the remaining part has to be 21. That's one way of thinking about it. I think it's kind of hard to think about it that way, though. It says, can we say the confidence that the triangle on the right is a right triangle? The answer to that would be no. The only way I would know that this is a right triangle is if they put that symbol in there for me. It looks like a right triangle, but remember, we can't go off of looks. Here we're going off the idea again of either a combination of the exterior angle equaling the sum of the two remote interior angles, or you can use the triangle angle sum theorem. It doesn't matter. But if this angle is 120 degrees, then we know that that one's 60 because those two form a linear pair. And by the same fact, we know that that's to be 60. So if that's 60 and that's 60, triangle angle sum theorem says that that x has to be 60. All right. Now it says identify the type of triangle provided and be as specific as possible. Okay. It does end up being isosceles, but we don't know enough. We haven't shown you enough to make that argument. And if we did choose isosceles, there's still a better answer. It's not scalene because we don't know anything about the sides. Okay. It's not right. Okay. So then it obviously has to be equilateral. Remember, we talked about a corollary that said all equilateral triangles are also equiangular, and that's what we have here. We have an equiangular triangle, so it must be equilateral as well. Okay, so option C is our best choice there. And like I said, it could be, you could have called it isosceles because all equilateral triangles are isosceles, but isosceles is not a better answer for this particular triangle than what equilateral is. Remember, equilateral is the most specific. Here it says you know that segment BC is parallel to segment FE. That was given right here. They want us to determine then the value of x. So when I highlight BC, which is that segment there, and FE, which is that segment there, and I start looking at that transversal, if I were to extend these lines far enough to where I see that normal parallel line transversal picture we get, we can see that angle right there and that angle there to be alternate interior. Okay, so if they're parallel, if the lines are parallel, then alternate interior angles are congruent. So this angle right here is also x. So now looking at this triangle, we have an angle of x, we have an angle of 90, and we have an angle of 52. So x plus 52 plus 90 should equal 180. We can subtract, find out what x is that way. This question again uses the combination of parallel lines and the combination of the triangle angle sum theorem, which is a practice that we're going to have to get better at, being able to combine multiple topics, multiple concepts inside of one problem. Okay, I had some questions about this one after the test. People saying, well, we didn't do this stuff, and we've been doing this stuff for a long time. It's, you've got a bunch of vertical angles here, you've got a triangle here, and you've got a triangle here. You should be able to use all the theorems and properties that we've discussed to come up with what this angle measurement out here is. So what you're going to do is you're going to start here at 75, and note that that's 75 because they're vertical angles. You also know then that that angle there is 45 for the same reason. Now if that's 45 and that's 75, that's 120 degrees so far. So you've got then 60 degrees left over for that angle. If that's 60 and that's 79, that's 139 degrees. Okay, so if I've got 139 degrees for those two angles, this angle here must be 180 minus 139. Okay. If that's the case, then 180 minus 139 is 41 degrees. So this angle here is 41 degrees. Okay. Now, from there, there's several things you could do. To find this angle out here, we could recognize that that angle out here is an exterior angle of a triangle. So that angle should equal the sum of the two remote interior angles, that angle and that angle. So I'll take 68 and 41 and add those together, and I get 109. Okay, 109 degrees. Okay. Another way to do it is to say, okay, if that's 41, that's 68, that's 109 degrees. So that means that this has to be 71 degrees. And now I can look at these two angles. These two angles as a linear pair. So take 180 minus 71, and I get the same 109 degrees for that outside angle here, that exterior angle. So we have seen questions like this. We didn't see this exact question, but we've dealt with vertical angles. This is a triangle angle sum theorem to find all these. There's linear, right? It's not linear pairs, but three angles that add up to a straight angle. Okay, and then we're coming over here to the either the triangle angle sum theorem again, or the idea that an exterior angle is equal to the sum of the two remote interiors. Okay, I gave you this one on accident, and I did go back through and give everybody credit for this question. But what we didn't, and I neglected to recognize this when I put this question in, but what I forgot to tell you, I guess I didn't forget, we see this in chapter 4, but what I overlooked is that this line here and that line segment are congruent. So that tells me the angle is opposite those lines. This angle there of 42 is opposite this segment. That means that this angle opposite this other congruent segment is also 42. Basically what we know is that in an isosceles triangle, that angle and that angle are the same. Now if we know that information, we could find out by the triangle angle sum theorem that 42 plus 42 is 84. So this angle here has to be 96. Okay. And now what we can do is look at that angle there of 96 plus x plus 12. That's an exterior angle, and that are two remote interior angles. So I can say 96 plus x plus 12 is equal to 2x plus 9 plus 3x minus 1. We're going to solve that equation then for x to get the correct answer. But again, I did give everybody that question correct. Next. Okay, 51 is the triangle angle sum theorem. They're asking us to find x and y. The two relationships you see is that that angle, and that angle are the triangle angle sum theorem. So we got 41 plus 8x plus 2y should equal 180. Okay, there we have two variables, so that's a problem. So now I'm going to look at that exterior angle and these two remote interior angles, and I'm going to say 12x minus 7 is equal to 8x plus 41. I'll subtract 8x from both sides and get 4x. I'll add 7 to both sides and get 48. So x then is equal to 12. Okay. Now, coming back up here, if x is 12, I've got 41 plus 12 times 8 is 96 plus 2y equals 180. Okay. Now that's enough information. I've gotten rid of my x, left with just a y now. I'll subtract I guess I'll go ahead and add these together, so we get, what, 137 plus 2y equals 180. I'll go 2y is equal to, subtract that, I get 43. Okay, so divide by 2 then, and y equals 21.5. And that's, so this was 12 and 21.5. This is kind of the same idea in the last couple of questions, but a little bit simpler. They want to know what x is, and I'm looking at this triangle angle sum theorem. So those three angles should have to 180. So we got 68 and 30, so that's 98. So this remaining angle has to be 180 minus 98, and that ends up being 82. So x is 82. And then if I look at y, well, y is a vertical angle, so y is also 82. So 82 and 82 there. Here we're dealing with the triangle angle sum theorem along with exterior angles. Okay, there's two ways you can approach this. You can say if that angle is 47, this one's 40, that's 87 degrees. So this angle here needs to be 93. Okay, so angle 4 is 93 degrees. If I know angle 4 is 93 degrees, then angle 3, which is its supplement, is going to be 87. Okay, notice that this is 87 because it is an exterior angle, and that's that angle and that angle are the two remote interiors. If I add those together, that should equal the exterior angle. And the final question asks us for the figure on the right, find the values and the measures of the angles. So there, triangle angle sum theorem again. So we're going 3x plus 4 plus x minus 9. Those should all out to 180. I'm now going to get 3x plus x, that's 5x. 4 minus 9 is negative 5, equals 180. I'll add 5 to both sides. I get 5x equals 185. So that's going to be 37. Okay, so x is 37. Let's come in here, 37. That tells me that angle R is also 37. Angle P is going to be 37 minus 9, which ends up being 28. And now 37 times 3 is 1, 2, so 90, came into 9, 11, so 111 plus 4 is 115. So angle Q is 115. If I go ahead and add those three values up, that should total 180 degrees. Remember that the retake will be Wednesday morning, 7:30 a.m. Hope to see you there if you are a person that needs to take the retake.